Hello, Mr. Cummings here, and in this video we're going to be taking a look at 1.1 Scalars and Vectors in one dimension. So the first order of business is going to be to define what scalars and vectors are. So scalars are just quantities that have magnitude. They have a size and that's it. Vectors are quantities that have both magnitude and direction. So I've listed examples that are related to each other but not exactly the same. So for instance, an object's mass is going to be a scalar because the mass is just how much stuff makes up that object, some measurement of that quantity. Whereas an object's weight would be a vector quantity because the weight is how gravity affects that mass. So the weight is going to be pulling down on that mass, so it would be a vector with a downward direction. Vectors are notated with an arrow above the symbol, so for forces, we'll have F with an arrow above it. For positions, horizontal position would be X with the arrow above it, so on and so forth. We won't always use the arrow above the vector. Sometimes we will drop them, and we're allowed to do this as long as we're dealing with information that's on a single axis. So brief note on magnitude, because this trips people up sometimes. Magnitude is simply just a measurement of size or quantity. So for numbers, magnitude is just the absolute value of the number. So if we had, let's say if you have a debt of negative $5, you owe your friend $5. The magnitude of that debt would just be $5. The negative sign would be dropped from it when you're talking about magnitude. For vectors, magnitude is the length of the vector. So it's just showing the length without the arrow. So if we have a series of vectors here, someone starts off at some origin. They walk 3 meters, or 3 units east, we can call it meters, 3 meters east, and then 4 meters north. So we could show this with 2 arrows. So here is the 3 meters east, and then 4 meters in the northward direction. So the length of these arrows would be the magnitude of those vectors, and if we have some line connecting them, the overall displacement vector here would be 5 meters, and that's just using Pythagorean theorem. It's a 3, 4, 5 right triangle. The direction would be northeast, but remember when we're talking about magnitude, we're just talking about the size of the vector and not the direction. So position is a quantity we're going to use in physics, and it represents some object's location on a coordinate system. We can show position as X or Y, a vertical or a horizontal position. The units that we're going to be using are meters, and it's a vector, so it has magnitude and it has direction. So let's take a look at 2 examples here. Let's say we've got Angela and Blake, and they're both located at these respective positions. X signifies the horizontal position. The subscript A here signifies that we're talking about Angela. So if we wanted to show where Angela is, let's call this right here our coordinate system, or our coordinate origin, 0 meters here. Angela would be located 3 meters to the right of the origin. Now Blake is located in the negative direction from the origin. So Blake is going to be located over here at negative 2 meters. So we'll draw a figure here, and this will be Blake. And since these are vectors, we can show their position with an arrow. So what we're going to do is we're going to draw Blake's position vector as an arrow starting from the origin, the horizontal origin, going to where Blake is located, and we'll call this Blake's position, X subscript B. Whereas Angela would be an arrow from the origin going to where Angela is located at the plus 3 meter mark. We could call this X subscript A for Angela. And those are our examples of position vectors. Displacement is going to be a change in an object's position. So we use a delta, or a Greek letter delta, or triangle in front of the position symbol to show that it's a change. And change is just a final value minus an initial value. So a change in position would be a final position value minus an initial position value. So let's take a look at Angela again. Let's say Angela is going to undergo some change in position. So Angela's going to start out at the exact same spot that we left her, which is going to be at the plus 3. So Angela is starting over here. And then she walks to the left 4 meters. So Angela is going to be displaced to the leftward direction, which is negative, so negative 4 meters. So we're going to draw, starting from where Angela is, we're going to just draw the displacement vector. So Angela's displacement is negative 4 meters. And so what that means is Angela is going to end up at a different position, a final position, over here. So Angela's final position will be at negative 1 meter. So when we're adding and subtracting vectors in one dimension, we're going to show that vectors that have different signs are going to be showing different directions. We'll generally use the following notation so that horizontal rightward will be the positive direction, whereas for vertical, upwards will be the positive direction. And a lot of times the way that you see this is that there will be a plus y on a coordinate system and then a plus x on the coordinate system, showing that right is positive and up is positive. Now, a small note here that we won't get into too much right now is that coordinate systems are flexible and they can be defined to suit our specific problems or situations. So up is not always positive. We can always change that however we want to. We can tilt this coordinate system, whatever we want to do, but more on that later. Another note here is that you can only add or subtract vectors and scalars that have the same units or the same dimensions. So for instance, if we said someone is moving 3 meters per second and we wanted to add the number 3 kilograms, which is a unit of mass, this does not make any sense because you can't add meters per second to kilograms. It doesn't make any sense. You can multiply them, but you cannot add them. So we will not be doing that. So let's take a look at an example where we do add vectors. So we're going to look at a vertical situation just to mix it up a little bit. Say we've got Aaron again, and Aaron is starting at an initial position of YA initial is negative 4 meters, and they walk to a final position of 6 meters. And we want to figure out their displacement, or in this case, their change in their Y position. So let's define our 0. We'll say 0 is right here on the sidewalk. And we'll say Aaron is located initially at this negative 4 meter mark. And we'll just say this is like a sidewalk and we're looking at it from top down. So Aaron ends up walking all the way up to the plus 6 meter mark, which is, I think, right here. No, right here. So Aaron ends up over here. So we know this vector that is separating these two is going to be our displacement. So we can show an arrow here going to Aaron's initial, and this is Aaron's displacement vector. But we want to calculate that. So let's go ahead and use our formula for calculating delta y. So we were careful to make sure that we included the negative signs in this calculation so that when we do this, we get 6 minus a negative 4, which we get positive 10. So Aaron was displaced in the positive 10 units in the positive direction. And this should be a y, not an x. Okay, so adding and subtracting position vectors or adding and subtracting vectors is not only limited to position, so we can do this with velocity as well. So let's say that we have some car, it's initially traveling in the negative direction. So we're going to draw a quick sketch of a square with wheels, we'll call this a car, and we'll say it's moving in this negative direction with some initial velocity of negative 5 meters per second. We know that it's going to change between the initial and final state. It's going to have a change in velocity of positive 4. And so we know the positive 4 is going to be directed this way, and this is the change vector. So the car is going to end up moving some different speed after this change occurs, and we want to figure out what that is. We also want to know, is it moving left or is it moving right? We can see it's still going to be moving left. but we want to calculate this value. What is our final speed of this car? So we're going to write the equation for a change in velocity, which a change in anything is always just our final value minus our initial value. And then we want to rearrange for the thing that we're solving for. In this case, it's the final value. So our final velocity will just be whatever our initial velocity is plus our change in velocity. We plug in our numbers and we calculate this final answer. And what we see here is that our final velocity is -1 meters per second. So important things to remember, scalars have only magnitude, vectors have magnitude and direction, and it's important to know when we're solving or adding or subtracting vectors that we are taking into consideration their appropriate signs. Thanks for tuning in to this video on scalars and vectors, and I'll see you next time.